just first 4 steps of an infinite pattern created by Sierpinski. Okay, it's the Sierpinski triangle apparently. The sequence begins with a black equilateral triangle, and each step is formed by removing an equilateral triangle from the center of each black triangle in the previous step. As shown. Each equilateral triangle that is removed is formed by joining the midpoints of each of the sides of a black triangle from the previous step. Okay. So in the first one, the number of black triangles, there's one black triangle and the fraction of the original triangle remaining. So it's all remaining. So it's 1 or 100%. Okay. In the next one, the number of black triangles is 1, 2, 3. And the fraction remaining is the 3 black triangles out of 4. So 3 out of 4. Yeah? This one then, the number of black triangles, if I can just mark them, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the fraction remaining is 9 out of 16, which they've done for us. So now I wouldn't try to count that last one. I just see, can I find the pattern? So this looks like times 3 times 3, which means times 3 again will give me 27. And the pattern here should be minus 3 over 4. Does that work? Sorry, times 3 over 4. So then, does that work? It does. 3/4 multiplied by 3/4 is 9/16, and then multiply that by 3/4, and we get 27 over 64. Yeah? Okay. Write an expression in terms of n for the number of black triangles. So, an expression in n for the number of black triangles. So is it just 3n? It's just multiplied by 3. So when n is 0, oh it's not, is it 3 to the n? 3 to the n. So when n is 0, you can see up here that the answer is 1. So 3 to the power of 0 is 1. When n is 1, according to up here, the answer should be 3. So that's 3 to the 1, which is 3, and that works. And then 3 to the 2, yeah, so that works. So it's 3 to the power of n. For the pattern, or for the expression even. Step K is the first step of the pattern in which the number of black triangles exceeds 1,000 million for the first time. Find the value of K. Okay. So if it's step K, then n equals K. So it becomes 3 to the K. Exceeds, we would do greater than. And greater than 1 by 10 to the 9? Yeah? So we're trying to get K, which is an indice, so we're going to have to take log to the base 3 of both sides. The log to the base 3 cancels with the log to the base 3, leaving you with K. And then log to the base 3 of 1 by 10 to the 9. I'm just typing into my calculator. And I'm getting 18.86. So step K is the first time. So it says K is greater than 18.86. So we'd have to assume K is 19. Yeah, so I'm going to try that. 3 to the 19. So I'm getting 116,226,146,7. Is that 10 to the 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1.16 by 10 to the 9. And I'm just going to check what 3 to the 18 was to make sure that's less. 387,420,489. 1, 2, 3, 4, 5, 6, 7, 8. That's 3 by, well, it's 3.8 by 10 to the 8. I keep rounding it wrong. 3.9 by 10 to the 8. Yeah? So the 19th term is the first time it goes over 1,000 million, which is a billion, I think. Step H is the first step of the pattern in which the fraction of the original triangle remaining is less than 1 over 100. Find the value of H. Okay, so this is a different sequence. So 1 3/4, oh sorry, 9/16 and 27/64.